Good afternoon, all. We'll wait for 5 more minutes so that if other people wants to join, they can join. Then I'll start. So it's almost time. So let's start. Good afternoon, all. Welcome to the second week of discussion session of course Finite Element Method. Course instructor of this course is Professor Bishwanath Banerjee and Professor Amit Shah. And myself, Asif Raza, I am your teaching assistant. I am a PhD scholar from Department of Civil Engineering, IC Bangalore. So we'll be discussing questions relevant to assignment number 2. I know that assignment 2 solution has also been published, but let's discuss today so that you may get the idea like what is really happening in the questions. So let's start. Uh, okay, so the first question is choose the correct expression for potential energy of the given bar Subjected to an axial load, consider displacement, area, and Young's modulus of the bar as U, 2A, E respectively. So I'll just try to ask questions to all. So what do you think? What will be the answers? Question 1. Are you guys there? Hello, am I audible? So, so what? So what's your guess? What should be the answer? I expect answers to be given soon because and assignment answers are published. So the questions asked in my discussion sessions are more towards closer to that assignment questions only. So please, any guesses? What would be the answer? No guesses. I didn't get any response. Okay, let's. Okay, I'll do the. So, what is potential energy? Potential energy is sum of strain energy minus work of the potential work due to the potential of the loads. So, strain energy would be given by if a material is having Young's modulus okay, I want if a body is having a Young's modulus as E, area as A, length as L, then it's given as EA du by dx whole square dx 0 to L minus, and this is the potential work done due to the potential of the loads. So as you see in the question, there is a P force applied, so P times and the displacement at this point. So if I take this as x equal to 0 and x equal to L, so what will have at u 0 equal to 0 and ul would be something. So this would be ul. Okay. Now if you guys ask like how this comes, this is what okay, EA by 2, sorry, this is EA by 2. How this comes is half times sigma epsilon dx 0 to 0 to L. Okay, and sigma is E epsilon, epsilon is strain, and strain in this bar question is du by dx. So if you substitute all this into the above equations, we will get as this only, du by dx minus p u of L, p times u of L. Now this is with regards when Young's modulus is E. This is with regards when Young's modulus is E and area of the material is A and length is L, and the displacement field is given by U. Now the question asked is U, the displacement field is U, area is 2A and E. That means E, 2A, L and U. So we just need to change this. So this will be half E times 2A du by dx square dx, rest will be same, So what will be having? So this will simplify and will have EA du by dx whole square dx minus p times displacement at L. So this is my potential energy of the given problem. So the correct answer would be option B. Okay, I hope nobody has doubt. Let's move on to the next question. So second question is, just a minute, I got a power cut. Am I audible? Can somebody respond that am I audible or not? Yeah, okay, fine. So this is second question. Uh, Second question is, there is a functional, linear functional with argument x, y, dy by dx due to y by dx square. So the correct option for Euler-Lagrange equation for this system, this functional, would be, so it's a straightforward. As you all know that the highest derivative involved is y double prime. So we'll just follow this rule. D by dx del f by del y prime plus the sign would be alternate, and this del f by del y double prime, this is y prime, this is equal to 0. So this is what we'll have as Euler-Lagrange equation for the system, and the correct answer according to this is option B. Okay, let's move on to the next question. So this question I'll ask you all. Can you guys respond in the chat box? Like, choose the correct option from the following statements for a governing differential equation with a highest derivative of second order. The highest derivative is of second order. First statement is Dirichlet boundary condition consists of only field variable, and the second statement is Neumann boundary condition consists of derivative of field variable. So first option is only first statement is true, second option is only second statement is true, or both statements are true, or both statements are false. So what do you think? What is the correct answer? Yeah, anyone? Abraham? Come on. Yeah. Yes, both statements are true. As the derivative involved is of second order, so when we will multiply with the weight function and reduce the continuity requirement. So we'll have one boundary condition of display as of the field variable and normal boundary condition as the derivative of this field variable. So both statements are correct. So now let's move on to the next question. Question number 4. So this is functional. This functional, and we have to write the Euler-Lagrange equation for this functional. So as we can see, the higher derivative involved is of first order. So what will be the Euler-Lagrange equation for this? This will be del f by del y minus first derivative is dx by dx of del f by del y prime, and there are no higher orders, so this is it. This is equal to 0. We are given with the functional x y y prime as 5x plus 8x y prime plus y prime square plus 7y prime plus 4y. So del f by del y would be, so 5x del f by del y it would be, so here is there, so 8x y prime, then 4, correct, and del f by del y prime would be 8xy plus 2y prime plus 7. Yeah, now we need to find the derivative of this del f by del y prime. So this would be equal to 8y plus 8xy prime plus 2y double prime. Okay, so substituting this into this Euler-Lagrange equation, we'll get the answer as, so we have del f by del y prime, del y is 8xy plus 4 minus d by dx of del f by del y prime, so that will be 8y plus 8xy prime plus 2y double prime equal to 0. So let's write it as a whole, xy prime plus minus 2y double prime equal to 0. This cancel out and we take it to other side, and the final answer would be 2y double prime plus 8y minus 4 equal to 0. So let's see what answer matches. 2y double prime 8y minus 4. The correct answer is option A. Okay.
Sir, can I get a bit more time?
Uh,
The third step d by dx of dou f by dou y
okay,
prime.
okay. I'll just show
The,
you
uh,
step by step. Okay, no
uh,
problem.
that third one, the red line third one.
This one, right? This one.
Yes.
Okay, no problem. Okay, I'll just move on this to down a bit. Yeah. So we need to find the derivative of dx of del f by del y prime. There, till this step you are okay, right?
Yes, okay.
Yeah. Okay. So we need to find the derivative of this. So let's take it individually. d by dx of 2y prime, d by dx of 7. So this will give me directly 0 as this is a constant, and if you see this one, this will give me what? 2 will get out. Y prime is what? Dy by dx. So if d by dx goes inside, it will be what? 2 d2 y by dx square. So that is what? 2y double prime, which is this one. Okay, just a moment. Are you with me?
Yes, yes.
So we got what? D by dx del f by del y prime as d by dx of 8xy. I'm writing this step here. Okay, this is the intermediate step. D by dx of 2y prime plus d by dx of 7. This is 0. This is 2y prime. This one you don't have any doubt, or this is also having some issues?
Which one, sir?
This one.
Yeah, that's okay now.
Yeah, okay. Now we are left with this. So we have to apply chain rule, sorry, product rule to this. So what will have 8 when we take the derivative of d by dx of 8xy, it will be what? 8x dy by dx plus 8y dx by dx. So this is what? 8x y prime plus 8y, which is what I wrote it here. It's fine.
Yeah, got it now. Thank you.
Yeah, you get this, like, see, these are partial differentiation. So we are taking the derivative of the functional with respect to y or y prime, but this is with respect to d by dx, and this is a total differentiation, not the earlier that was partial. So here we have to take every term and differentiate it with respect to x. So if it is y prime, it will get, when we take the derivative, it will be d2y by dx square. So likewise, if other higher order terms are there. I hope you are clear in this regard now.
Yes, 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 sir.
Yeah. Okay. So okay. Now let's move on to the next question.
Sir, just a few seconds to complete the last two steps.
Okay.
Uh,
Okay.
ju-
Okay. Should I reiterate?
no, 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 no. Just keep the screen for a few seconds.
Yeah. Okay. No problem. So this is what del y by dou f minus d by dx of dou f by dou y prime equal to 0.
It's over, sir.
Yeah, okay, fine. Let's move on to the next question. Question number 5. Question is, let the governing differential equation for a simply supported beam having length L, Young's modulus E, and moment of inertia I is EI. Fourth derivative of W is equal to Q. Consider the beam is subjected to uniformly distributed load of intensity Q per unit length, which results in vertical displacement W. So number of required boundary condition is. So I'll ask you all, what would be your guesses? Just try to uh, say anything, like, what do you think? What would be the answer? Number of required boundary condition. Come on. Priyansh has given his answer as 2. What about others? You can write I don't know, then I can proceed to explain also. Abraham has said 4. Shalu, are you with me? Any guesses from your side? I don't know whether she is here or not. Okay, Abraham has said option as 4. Yeah, correct answer is option 4. So, how do you get this thing? If you guys are not, if you guys don't know, I can explain. I'll just take this black one. So we have EI dw fourth order of equal to Q. This is my governing differential equation, right? So I can write it like this: minus Q equal to 0. For getting the boundary conditions, what do we normally do? We uh, multiply it with a weight function, right? So weight function, if I multiply this, suppose I take nu or gamma as my weight function, so it will be like this: minus q dx 0 to L equal to 0. Now we apply uh, integration by parts. So first let's do this step by step so that you guys don't have any problem. I'll just divide this dx4 dx equal to 0 to L gamma q dx. I don't think you guys would have any doubt here. Let's solve the other steps. Now I'll apply chain rule here. So ei is a constant if taken constant. So now applying integration by parts, we get what? Ei, this is my first function, this is my second function, so d sorry ai gamma d cube w dx cube, this will become like this, minus, so this is what, this will be my boundary condition at 0 to L, minus 0 to L d gamma by dx ei dq wx cube dx. This is the left hand side, LHS. Okay, if you are not aware of this one, we are using integration by part, and that is solved like this: u v dx, so u v dx minus du by dx v dx. Okay, and this has a whole dx du by dx v dx. We are using this here. Now we again apply integration by parts. Again apply integration by parts. We get what? LHS is, this term will remain same, ei gamma dq wx cube 0 L minus, so integration by parts. So this is my first term, this is my second term. So what we'll have, So you take the first term as it is and apply the integration over the second term. This will be my boundary condition, and the fourth integration term would be d square dx square ei dw dx square dx. So this is what we have in the, this is what we'll get in the LHS. So as you see, so RHS we have as integration of 0 to L gamma q dx. Okay, so our total like weak form becomes, if I can write it properly, 0 to L d gamma dx square ei dw dx square minus d gamma by dx ei d2w by dx square 0 to L plus ei gamma dq w by dx cube 0 to L, and one the right hand side is equal to 0 to L gamma q dx. Okay, so this is what we have as a weak form. Strong form we had, should write it down. Strong form we had as ei d to the power 4 d x4 equal to q. This was our Euler-Lagrange equation, or my governing differential equation. So this strong form should come with boundary conditions, right? These boundary conditions are incorporated in this equation. So if you see, this is what the boundary conditions are. Here there are two boundary conditions, here there are two boundary conditions, right? So the total number of boundary conditions as asked in the question, the number of required boundary conditions is, correct answer would be option 4. So those answers are coming from this section, this part. So to make it clear, I solved this thing. I hope you guys have no problem now to understand this. So now I'll move on to the next question.
Sir, a doubt.
Yeah,
Sir, can we just guess from the power of the equation?
yeah, for sure.
Okay.
Like the whatever is the highest order of this
Order.
differential
Yes.
equation, so that will be that much will be my boundary condition. So if I have my order of equation was fourth, we have four boundary condition. This is for the case of beam. If we had a bar, as we know the highest order involved in that differential equation is 2, so we require two boundary conditions in that. Correct, like in the bar, if there is a question we apply here. So what are we doing exactly is we are restricting one differential boundary condition as our displacement, and we apply some load at some boundary, this boundary. So we say we are applying the load over here. So we give one more boundary condition there. So total two boundary conditions are involved, and the governing differential equation, the order for that was 2, while in the question asked here is the 4. So directly the number of boundary condition would be 4. So okay, if I ask you like what will be the number of essential boundary conditions and number of normal boundary conditions, so what will be your answer, Abraham?
Sir, can you repeat the question?
I'm asking, like, as you have given answer, like the number of required boundary conditions to the fourth order differential equation according to this question is 4, correct? So with regards to
Yes.
this question, if I
Yes.
ask you how many would be essential boundary condition and how many would be uh, normal boundary condition, I suppose you know what are essential and what are normal boundary conditions.
Mm,
This was asked just a moment ago.
yes.
So I think you know. So what is your answer?
Two each.
Yeah. Yes. Yes. You are correct. So these boundary conditions come in pairs, like number of essential boundary conditions and number of normal boundary conditions will come out to be equal. So if you see the essential boundary conditions, the order derivative is lower on the lower side, while the normal boundary conditions they involve field derivatives. So in this question, if I ask you, if I say what will be the order for my Dirichlet boundary conditions, like if I say Dirichlet boundary conditions. So in these questions, if my field variable involved is W, so as you said that there will be two each, correct? So the or given would be either this W at all the points, all the boundaries, or dW by dx. And normal boundary conditions will be uh, d square W by dx square and d cube W by dx cube. Like either this will be given or this will be given or both will be given, but not at the same node. Okay. So if you see in the question, like as I solved for the weak form, you see these terms are coming up, like d2w by dx square is there, d cube, uh, see d cube third order derivative of w is there, and the Dirichlet boundary conditions are what taken from the weight functions order. Okay, so I hope no problem is there in this regard. Let's move on to the next question. So sixth question, we have a cantilever bar fixed at x equal to 0 and free at other end of length L. This is a bar, okay, of length L, area A, Young's modulus E is subjected to an axially distributed load Q if nu is a weight function. uh, this bar problem can be expressed with any of the following two forms. So F1 is given by this, F2 is given by this. So the correct option is, first option case is F1 is weak form and F2 is strong form. Second option is both F1 and F2 are strong form. C is both F1 and F2 are weak form. Fourth option is F1 is strong form, F2 is weak form. So guesses please.
F1 comes as a differential equation with the two boundary conditions, so that will be strong form.
Yeah.
And F2, it's weak form.
Yes, because as you can see, weight function is involved in this equation. Correct. So this will be weak form. So in this regard, option D would be the correct answer. So okay. So to give more clarity, as what I was saying earlier, this was what a fourth order, right? So we had Dirichlet boundary condition as 2, and Newman boundary condition as 2, and order were like W dW by dx, second order, third order. Now this is a question, if you see, this is a second order, correct? So the boundary conditions are given two, one essential boundary condition and one normal boundary condition. So I hope this gives you more clarity, you can think more about it. One thing more to see is, essential boundary conditions and normal boundary conditions should not be given at the same point, like at x equal to 0, at x equal to L. We can't have like AE du by dx is equal to 0 at x equal to 0. That would be like that is saying like you are fixing here, you are not allowing to displace it, and you are applying load over here. So what will happen to this question? Nothing. You are not doing anything to this. So this should not be, the case. Okay. So now let's move on to the next question. Question 7 says, anyone has doubt?
Sir, that F2, can we have that expression?
Oh,
From the
derivation.
no, 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 no. Just so from this, as in the previous case, can we find which is the essential boundary condition and Neumann?
Yeah, you can
F2.
see boundary condition is this one. You can see. Okay, I'll just write it more clearly. I don't want to mess it there. So we have equation as, this is my boundary condition given, 0 to L d nu by dx AE du by dx equal to 0 to L dx. Okay, so if you see this part, right? So Neumann boundary conditions appear in the boundary condition as their derivatives itself. Like if you are taking the field variable involved in this equilibrium equation is u. So the derivative of u in the boundary condition is my Neumann boundary condition. So here my Neumann boundary conditions derivatives involving would be du by dx, and essential boundary conditions would be the order of my weight function in the boundary condition, and this is this one, essential boundary conditions. So here we see that's gamma. Gamma, no, the question has taken nu. Okay, so nu is similar to this W itself, that if nu is having, if nu had been d nu by dx, then would have said that boundary conditions should be dw by dx, but it's just nu. So just replace nu with u. So my essential boundary condition would be u. So this is what is there in the boundary conditions defined also. If you see, the first boundary condition is essential, second boundary condition given is Neumann. It involves the derivative of u. Okay, is it clear now?
Okay, okay, okay.
Yeah, okay. So now let's move on to the seventh question. So seventh question, simply supported beam having length L, Young's modulus E, and moment of inertia I is subjected to UDL of intensity Q per unit length. The vertical displacement and weight functions are W and V respectively, the weak form for this beam is. This is quite straightforward, but okay, let's okay, first I'll ask you all, what do you think, what is the correct option? This is similar to what I solved earlier. This one is what, this is what being asked. So what would be my answer? Weak form for this beam is. As just solved earlier. Governing differential equation is what? EI dw EI t to the power 4 w by dx4 to q. This is what the governing differential equation. We need to find the weak form pertaining to this. What will be my weak form? I just solved earlier. Come on.
A.
Yes, A is the correct answer. Uh, this can be like weak form. I can in some other way also. That weak form is written like this. B. So your question, with regards to the question, we have WV equal to LV. Okay, I can write VW. This is bilinear. This is the linear. So just to give a quick, I'll not go step by step. I'll just say solve directly. This is my differential equation. I'll just multiply with my weight function, integrated over the domain. Uh, Applying integration by part, what we'll have is t2 nu dx square plus ei d square w by dx square dx integrated over the domain 0 to L dx plus some boundary conditions equal to 0 to L nu q dx. Okay, so when we substitute this boundary condition, this becomes, this can be removed. So this is what B V W, and this is what L V. So this is what is my weak form. So with regards to that, the correct answer is option A. So okay, Aparna has asked like, is this recorded? I said yes. So she asked where can we access it? Okay, so I think you guys have been provided the link, I think, or I don't know whether if it has been provided, but I know for sure that it will be provided in the future. There is a I used to publish this into a YouTube channel as well, so you guys can directly access it. So okay, no problem. You guys will get the access in the later. So you can view the lectures as an audio thing, as well as the notes which I am giving, right, on which I am working, that is also being uploaded in that Google Drive, so you guys can access there. So no worries in that regard, you will get the recording as well, so no problem. Now let's move on to this 8th question. Choose the correct option from the following statement. First statement is strong form of a physical system is satisfied at each point of that system. Weak form of a physical system is a weighted integral form of strong form. Third statement is weak form of a physical system also strongly satisfies at each point of that system. So there are four options. Come on, answers please. Guesses.
One and two are true, but not sure about third one.
Not sure. Uh, what about others? You can unmute and say. Only Abraham is responding. Others, please. Okay. So Abraham, I'll just uh, give you. If you observe second statement and third statement, you see those two are kind of a contradictory. Weak form of a physical system is a weighted integral form of strong form. Weighted integral means as in like uh, not at every point, but as a whole domain, it's satisfied in a weighted sense. And third, it says that it strongly satisfies at each point of the system.
Oh, correct,
So,
correct.
so
So third one will be false.
yeah. And one more way you can think of it, like why is it called strong form? Why is it called weak form? Strong form means strong continuity requirement is there. Like it should be satisfied at each point of the system. So that is like a strong requirement, right? So that's why that is called as strong form. Weak form is you don't want to satisfy, like you want to satisfy, but to get by with just an approximation, you want to say that I want to satisfy the equation in an integral sense, like it should be equal to 0 as in whole domain, not at every point, but as in weighted sense. If I like somewhere it's plus, somewhere it's minus, in a whole sense it will give me as a sum equal to 0. So with that regard, 1 and 2 are true, but 3 is false. So option C would be the correct answer. Let's move on to the next question. Let a differential equation is this. These are my boundary conditions. This is what? Essential boundary condition. This is one boundary condition. As you can see, this is a second order derivative. So one would be essential, one would be non-boundary conditions. Correct. So let a differential equation, we are given with differential equation, boundary condition, and it further says a bilinear and linear functional as this respectively with v as weight function. The correct option would be, so what would be my bv and lv? Okay, so this can be solved step by step. I'll just write it. So we are given with the differential equation as this, x cube equal to 0, correct, with boundary condition u equal to 0 at x equal to 0 and du by dx equal to 1 at x equal to 1, correct. So to find this bilinear and linear, we need to convert this strong form into weak form. For that we multiply this thing with v d square u by dx square plus u square plus x cube dx So what the domain L equal to 0, such that this new should satisfy homogeneous counterpart of essential boundary condition. What does it imply is we have this essential boundary condition, right? This is normal boundary condition. So this is at x equal to 0. So this implies that nu should be 0 at whatever my essential boundary condition, like this is u. So directly we are saying nu is 0 at x equal to 0. So this must be also equal to 0. There could be like question could have been like u equal to 1 at x equal to 1. That could also be there, x equal to 0. So even then we have to write the boundary condition for this weight function as 0. That's why it's called homogeneous counterpart of essential boundary condition. So nu equal to 0 at x equal to 0, this would be my condition to multiply my weight function with the governing differential equation. Now we do the integration. So okay, just not leave any steps so that you guys don't feel confused about it. So I'll take these statements on the right hand side. 0 L V u square plus x cube. This I will take it here, it will be minus dx. Okay. Now this LHS 0 to L V d square u by dx square dx can be solved by d square u by dx square, right? Yeah. So this can be solved by taking integration by parts. So what we'll have, first we'll get a boundary condition as v integrate the second function. This is my first function, this is my second function. So first function as it is, integrate the second function on the boundary, then integration of, so we take the derivative of the first function, the integration of the second function, and integrate for the whole domain. So this is what we get for like boundary condition, on integration by part. So let's simplify it more. So what will have, v du by dx, all these at x equal to L, minus v du by dx at x equal to 0, minus integration dv by dx du by dx integrate to the domain. As you have seen earlier that as I told you, the new v is equal to 0 at x equal to 0. So what will that imply is this will become 0. Okay, and we are given with the boundary condition as this, that is du by dx is equal to 1 at x equal to L, right? So this can be simplified as v at L. Okay, I better write it more simplified way, at L minus v at 0 du by dx at 0 minus 0 to L dv by dx du by dx this is VL, this becomes 1, this becomes 0 times du by dx, 0 0 to L dv by dx, du by dx. Okay, so this is finally VL minus 0 to L dv by dx, du by dx, dx. So if I write it, RHS was what? Minus 0 to L, you know, VU square plus x cube dx. Okay, so you write the complete statement as again. So LHS is VL minus 0 to L dv by dx, du by dx, dx equal to minus 0 to L VU square plus x cube dx. Okay, so what we'll do is we take this part, we'll multiply minus on the both sides. Okay, and okay, just I'll do the step by step. So we have what? 0 to L dv by dx, du by dx, dx minus VL equal to 0 to L VU square dx plus 0 to L V x cube dx. So this thing can be again written as 0 to L dv by dx, du by dx, dx. Take this term on the left hand side, we'll have 0 to L VU square dx equal to, take this statement, take this term on the right hand side, so we'll have 0 to L. So we have now this plus V of L. Okay, this thing can be written in a compact form as dv by dx, du by dx minus VU square dx equal to 0 to L V x cube dx plus V at L. So now this you can observe is this term is dependent on U and V, and these terms are dependent on V. So as asked in the question, we need to find the bilinear term B and linear term L. So with that regard, BVU would be this. So dv by dx, du by dx minus vu square, dv by dx. So with that, either option this and this. So we need to match this or this. So we have this as a linear term. So correct answer would be option C.
Sir, sir, can I ask something?
Yeah, sure.
Sir, from 0 to L, the boundary condition in the answers we have 0 to 1. So how did we arrive?
Okay. Okay. Uh, so just replace L with N. I took the domain as 0 to L. So you can just replace everything as the domain given. Oh, okay. There is a typo here. There's a typo here. This is
Okay.
one. Yeah. You pointed out correctly. Domain is 0 to 1. Then only everything is been given in terms of 1 only. See, the domain integration is done from 0 to 1. Yeah, you pointed out correctly. So like if domain is given from 0 to L, then boundary conditions would be like it will given at x equal to L, and suppose for respectively that the equations will be like from here for 0 to L, and this will be at V at L. If it is from 0 to 1, so this is at 1. Okay, no problem. Yeah, can I move on now?
Yes.
Yeah, okay. Yeah, so this is the 10th question. 10th question is choose the correct option from the following statement. First statement is strong form of a physical system is obtained from Euler-Lagrange equation. Second statement, Rayleigh-Ritz method is a variational method which provides approximate solution of a physical system. Third is weak form consists of only linear functional. So there are four options. First option says that only third statement is correct. Second option says that only first and second options are second statements are correct, but third statement is false. Third statement option is first and second are false, but third is true. And fourth option is all three are true. So what do you think correct answer would be?
First one is true.
Okay.
Second one is also true. Uh, Third one is false. Bilinear can also be.
Yeah, you got it correctly. So uh, so with that regard, option B would be there. So you uh, got it correct that weak form consists does not consist only of linear function, it consists of bilinear. Just we said right now. Weak form is what? Bilinear and linear, both terms are there, right? So yeah, so you're correct. So this is 11th question. This was what was given in the assignment. I think you guys uh, know the answer, but I don't know whether you guys know the uh, procedure to solve it.
I don't know the procedure.
So uh, I could also say directly if given with the options like question is what we are given with this differential equation and domain is from 0 to 1, which is subjected to the boundary condition that u at 0 equal to 1 and u1 equal to 1. So boundary conditions are this: consider u bar as one parameter approximate solution of u with this phi naught x and phi 1 x is given this. Nu is a weight function. What is the approximate solution u bar considering Rayleigh-Ritz method? So okay, so out of these options we can directly observe one thing is that we are given with the boundary conditions as this: u of 0 equal to 1, u of 1 equal to 1, correct? So normally you'll see generally you'll see that we want that when we know first hand what are my values at my boundary condition, we would want my approximate solution to at least satisfy answers at those boundary conditions itself. So if you substitute, these are like MCQ kind. If you try to want to know the answer without knowing the procedure, you can directly eliminate it. So if you just substitute, like if you substitute 0 for in all these options, you'll get 0. Sorry. Uh, oh, yeah. This is something. Okay, something is fishy now. Okay, I'll just do the procedure better, saying something. So we are given with the differential equation as this for domain x to 1 with boundary condition u of 0 equal to 1 and u of 1 equal to 1. u bar is being told that our approximate solution u bar is C1 phi 1 plus phi naught, and phi naught is also being provided as x, and phi 1 is equal to x times 1 minus x. Okay, so with that my approximate solution would be what? C1.
Sir, can I ask something here?
Yeah.
So, is it okay to assume this phi 0 and phi 1 for any given question?
Come again, I didn't get it.
Sir, pardon?
I didn't get your question, can you repeat once again?
Actually, in the video, when Sir solved a problem, there
Yeah.
also he took phi naught and phi 1 as the same x and x into 1 minus x.
Not
So,
necessarily, but why is this being taken
uh,
is because if you substitute x, uh, as I told you earlier, that weight function need to satisfy the homogeneous counterpart of essential boundary conditions, right? So what are my boundary condition is this. So nu 0 must be equal to 0, nu 1 must be kind of 0, right? So if I uh, uh, see in that regard, so this will satisfy that thing, this. And phi naught is something related to translation, but it's not mandatory to use this. Like this is given, already given in the question, that phi 1 is this and phi naught is this. This is not mandatory. You can take like you can take phi naught as x, phi 1 as x square, phi 2 as 1 minus x square. That won't be the problem. It's just like that u bar is what, c1 phi 1, c2 phi 2 goes on cn phi n plus phi naught. So these things will change accordingly. Okay, so that.
uh, okay, sir, I have a doubt about that homogeneous condition. Does it is it always that the right hand side will be zero, homogeneous?
Yeah, homogeneous equations implies that when you substitute into those uh, uh, like for x equal to 0 anything, it should be equal to 0. It should not be equal to some constant. What I meant is y equal to mx plus c. If it is this is not a homogeneous equation. Mx minus, what I can simplify is mx minus y equal to 0. It's not there. It's coming out to be minus c. This is not 0. So this is not a homogeneous equation. When I
Okay.
substitute, when I substitute like everything 0 0 0,
Okay.
so the like both sides should satisfy uh, 0 thing, right? But this won't be the case here. Like if I substitute y equal to 0, x equal to 0, c will be remaining on the right hand side, which won't be equal. So that's a requirement for this weight function. But that is not in regards of Rayleigh Ritz method. This is in regards with weighted integration, like when we try to develop this weak form. This is not specific to Rayleigh Ritz method. Okay, so for that I told you you can take any weight functions, but that with that regards my C1 C2 will change. Okay, so let's try to solve this. 2 plus, okay, I'll erase this one, this is not needed. So we have C1 x 1 minus x plus phi naught is x. Okay, this is my U hat. This is what we want to find. For this we need to find C1. Okay, now okay, uh, I just got one idea as this: C1 x square plus x. Now we have, I think there is something, this is what, C1 plus 1 x minus C1 x square. Okay, so uh, you can I was trying to see whether I can solve using the options directly if I take this. So if I see the option A is given as 5 by 7 x square plus 9 by 7x. So uh, if I compare this, if I see this term, C1 will come out to be minus 5 by 7. C1 plus 1 is what? Minus 5 by 7 plus 1, that is 2 by 7, which is not the case here. So option A won't be the correct answer. Okay, I'm trying to eliminate like this, then we'll go with the actual procedure as well. Second option is minus 5 by 24 x square plus 29 by 24x. So with that we have C1 is equal to minus 5 by 24. C1 plus 1 will have minus 5 by 24 plus 1. 24 plus 1 gives me 19 by 24, right? So okay, sorry, C1 will be minus 5 by 24 because this is minus 1. Okay, so this will come out to be 29 by 24, which is compliance with this. So with this regard, it seems like option B should be my answer. Let's check other options as well. Minus 5 by 24 x square plus 1 by 24. Minus 5 by 24 x square plus 1 by 24 x. As we just saw that when C1 is 5 by 24, C1 plus 1 should be equal to 29 by 24, which is not the case here. This won't be the answer. Option D is 2 by 7x square minus 9 by 7x. C1 is minus 2 by 7. C1 plus 1 is minus 2 by 7 plus 1, 7 minus 2, 5 by 7, which is not the case. So we can directly see from the options now that option B would be my answer. But let's try to solve this with the actual procedure. Okay. So now let me see again the question. I'll just mm, 2 plus x square, come on again, 2 plus x square, 2 plus x square d to u by dx square plus equal to 0. This is equal to 0. U at 1 equal to 0, U at 0 equal to 0. I suppose no one, everyone is 1. Okay, and U bar is C1 phi 1 plus phi naught. Phi naught is equal to x, phi 1 is equal to x1 minus x. So with this give me U bar as C1 x1 minus x plus x. Okay, now let's solve it step by step. If I multiply the governing differential equation with nu, okay, 2 plus x square d square u by dx square over the domain 0 to 1 equal to 0, right? Now apply integration by parts. What do we have here? 0. This is where I was having doubt a bit. My second function is what? This. This is where I faced doubt somewhere. Okay, let me see once again. So new, why not? This is what I was having doubt. Let's try it. Okay, so if I do the integration by parts, what we'll have is new integrated of this part 2 plus x square d square u by dx square. This should be integrated. I will just write this thing. I'll just write I as 2 plus x square d square u by dx square integrated since. Okay, 0 to, we don't have L, right? 1 1 1. So let's do the integration by parts to this question. If I try to do the integration by parts to this, what we will have is okay, we can do one thing is I'll take this thing as a first function rather that thing, because that makes it complicated. So integration by parts will give me 2 plus x square, the first function. Let me write it again here, that integration by parts is what? First function, second function. We take the first function as it is, integrate the second function, minus the integration of, then differentiation of the first function, integration of the second function, integrated as the over the whole domain. So this is what is integration by parts. Let's try. I'll use this one as u, this one as v. So this will be okay. So just new 2 plus x square d square u by dx square dx 0 to 1 would be equal to new 2 plus x square integration of this, so this will give me du by dx over the domain integration since 0 to 1, then minus differentiation of this first function, so this will be what, d by dx of gamma 2 plus x square, then integrated sense of this du by dx and again integrated 0 to 1. I hope this statement is clear. Then this is x. I better write it again now. So this can be nu at 1, 2 plus 1 du by dx at 1 minus nu at 0, 2 plus x 0 will give me 0, and du by dx at 0 minus minus 0 to 1 d by dx okay. Should I substitute? I better leave it now at this point only. I'll just leave it here as of now. Let it be equation 1. Now this is what we had. Okay. Okay. No, better proceed further. I'll again write it 2 plus x square du by dx. Taking a lot of time here. Okay, 0 to 1. It will be what? I better substitute gamma. Gamma is some. It will be phi 1. But whether I should or I should not, that's the question. Okay, so we have d by dx of gamma 2 plus x square gamma du by dx integrated over the domain dx. This is what we have as an integrated sense of this, right? So if we substitute gamma as phi 1 and u as substitute gamma as phi 1 and u as u hat, that is what, c1 phi 1 plus phi 0. Okay, let's do this. So that will be equal to what, phi 1 plus 2 plus x square d u hat by dx 0 to 1 minus 0 to 1 d by dx 2 plus x square gamma is what, phi 1 d u hat of dx as an integrated sense. Okay, now we'll substitute phi 1 also. uh, Substitute everything now. This is equal to what? 0. These things are equal to 0. Equal to 0. 8. So substitute phi 1 was what? X into 1 minus x, and so u hat will be equal to c1 x 1 minus x plus x. Okay, so substitute in the above equation. We get, so phi 1 is what? X into 1 minus x, okay, then 2 plus x square, then du hat. I better substitute, I should write this one also. So what will be du hat of dx when we have u hat as this? Du hat of dx would be c1 times 1 minus x plus minus c1x plus 1. We differentiate this one, so this can be again simplified and written as c1 is equal to 1 minus 2x plus 1. Okay, now substitute this phi 1 u hat and du hat by dx in the above equation. We will get as phi 1 is x 1 minus x times 2 plus x square. Du hat is c1 1 minus 2x plus 1. All thing at the boundaries minus 0 to 1 integrated sense. We need to differentiate this thing. Okay, better before that I should solve that part, otherwise it will be so. I'll solve this one. Okay, so d by dx of 2 plus x square phi 1 is d by dx of 2 plus x square. Phi 1 is x 1 minus x. So this is apply the product rule. So we'll get here we have 2x times x 1 minus x plus, if we don't take this one, then this will be 1 minus x plus 2 plus x square x times minus 1. This will be equal to 2x square 1 minus x plus 2 plus x square 1 minus x plus this is 2 minus 2 plus minus x 2 plus x square. Okay, so we substitute this on So this will be equal to what? Completely 2x cube plus, I've made a mess completely. Okay, so this will be again 2 plus x square, then minus 2x minus x cube minus 2x minus x cube. This will be simplified as, okay, x cube is this one, this one, this one. So minus minus, this will be equal to 1 2 3 2 1 4 minus 4x cube, then x square is this and this term, so this is 3x square, x is minus 4x. I hope this is correct. If you guys find any type mistake, please do inform me. So this is what we get the differentiation of this. Okay, now let's substitute everything into above equation. So what we are trying to find, let's write it again, is this phi 1, come on. Okay, so this is what we are trying to find. X 1 minus x 2 plus x square, c1 1 minus 2x plus 1 at the boundaries 0 to 1. Okay, I can erase this part now. Minus 0 to 1, this one 4x cube plus 3x square minus 4x times du prime by dx. Du prime by dx is this c1 1 minus 2x plus 1. c1 1 minus 2x plus 1, right? Yeah, integrated sense equal to 0. This is a big straight. Okay, substitute 1. If you substitute 1, this will be 0. If you substitute 0, this will be 0. So that is 0. Okay, so boundary terms are 0. We'll just write it here. These are 0. Now this one. So we have, I can take this negative as positive now, and we can write minus 4x cube plus 3x square minus 4x integrated on this domain 0 to 1. C1 1 minus 2x plus 1. If you multiply 1 also again, so we'll have this 0 to 1 minus 4x cube plus 3x square minus 4x dx. This is also dx equal to 0. Okay, mistake again. Now do the integration. Okay, that's a bit complicated again. So take the c1 out, minus 4x cube plus 3x square minus 4x, okay, minus 2x is multiplied with the again, So 2x would give me 8x4 minus 6x cube plus 8x square dx plus 0 to 1 minus 4x cube plus 3x square minus 4x dx equal to 0. So simplify it. Can C1 0 to 1 8x4, then x cube is 6 4 10 minus 10x cube, x square is 11 minus 4x, right, dx plus 0 to 1 minus 4x cube plus 3x square minus 4x dx equal to 0. Okay, so integration will be 8 by 5 x5 minus 10 by 4 x4 plus 11 by 3 x cube minus 4x square by 2. All integration to be done from 0 to 1 plus 0 to 1 is plus, right? Yeah. Minus 4 by 4 x cube plus 3 by 3 x cube, oh, this is x4 x cube minus 4 by 2 x square dx equal to 0. Yeah, just demarcate the okay, so this will be equal to what? C1 8 by 5 minus 10 by 4, that I should write it properly. Eight by 5 minus 10 by 4 plus 11 by 3 minus 4 by 2. This will be equal to, this is not an integration, this is integrated in the boundaries. Now values will be minus 1 plus 1 minus 4 by 2 is what? 2 equal to 0. So this will be what? C1 8 by 5 8 by 5 minus 10 by 4 is 5 by 2 and it 11 by 3, 10 plus 4 what? 5 by 2, 5 4 9 by 2, and this is equal to 1 minus 1, this is minus 2 equal to 0. C1 equal to 5 3 is 15 to 30. So this says 30, right? 48, then 15. Yeah, 35, 30 equal to 2. 2 into 30 by 48, 135. 58 minus 35 is 38, 28, I think. 58 minus 35. 58 minus 35 plus 10 plus 10 to 10. 23. Somewhere I made a mistake, I think. it should come out to be 24. There have I made a mistake. Have I made any mistake somewhere? 158 minus 35 is 38. 38 is giving 23, but should come out 24. Should have come out to be 5 by 24. Made a mess somewhere. Let me see. The edges. This is the equation. X square 0 equal to 0. 2 plus x square. Abraham, have I made any calculation mistake somewhere? Did you observe any?
Sir, I couldn't identify.
Okay. Let me see. Gamma 2 plus x square d square u by dx, right? D square u by dx square. U0 is 1, u1 is 1. U0 is 1, u1 is 1. That is not regard. So d square u by dx square, we integrated u, when we integrate it, this will come out to be integration of this second term, this differentiation of the first term, then integration, then this is correct, I think. Okay, come on. Gamma times 2 plus x square d square by dx, gamma times 2 plus x du by dx minus, so we take this part, substitute gamma as 5(1), u as u have, u as 1, and u as gamma as 5(1) is 5(1) times 2 plus x square du hat by dx1. Okay, so that is equal to 0 at boundaries for sure, yeah. So that is of no concern. Now this is relevant to us. So du hat by dx, u hat is c1 x1 minus x plus x, c1 minus c1 plus 1. So this is 1 minus 2. C1 minus 1 x minus 1. Okay, this is correct, I suppose. Then this one is u2 plus x square 5(1), d by dx equal to x times 1 minus x. I've taken 5(1) correctly, right? X times 1 minus x, yes. X times 1 minus x. X times 1 minus x. Then 2 plus x square, derivative will be, when I take the derivative, that will be 2x. 2x times x minus 1 minus 2 plus x square, derivative will be 1 minus x. X minus 1, okay. Then 2x square 1 minus x, 2 plus x square 1 minus minus x, 2 plus x square, this is also correct. Then this is equal to 2x square minus 2x cube plus 2 plus x square. minus 2x minus, okay, no, he said no, and 2 plus x square minus x, so minus 2x minus x cube, okay, minus 2x and minus x cube, so this will be equal to minus 2 3 minus 4x cube 3x square 2 plus 3x square 2x minus 4x. Oh, I missed here 2 plus 2, this one. So what will be the corrections pertaining to this? Made a mess, now I have to clean it up. Minus 4x cube plus 3 4x square, this was to be substituted here, right? Then minus 4x plus 2 here, right? So I'll have to just add it here, plus 2. I suppose you're getting what am I doing, right? Where I made a mistake. So just correcting everywhere, plus 2. So here it will be equal to minus 4x cube plus 3x square minus 4x. C1 is out. We have to write 2 minus 4x. Yeah. Okay, and 2 here, so this will be equal to plus 2. Then let me see, yeah, yeah, okay. Now when I correct this thing, we have an addition of uh, minus 4x plus 2, and here only plus 2. So with that we'll have an addition of uh, minus 4x square by 2 plus 2x, and here we'll have an addition of plus 2. So this will have an extra term minus 4 by 2 plus 2, and this will have an additional term of 3 by 3 4 by 2 plus this will have an additional term of, okay, did I mean to say this? Acha, we have to integrate it. 4x square by 2, this will be 2x, so this will be 2 only. What is it? It came out to be 0. Okay, it's almost time.
We will work it out, sir.
Yeah, I'll try
So,
to solve this and post it in the discussion forum. I think
yeah.
I'm making somewhere mistake. I'll just try to go it carefully. Okay, if you guys have no issues in this, other than this, then we can wrap it up for today. If you're fine.
Yes, sir.
Yeah, so okay then. Take care. Have a nice weekend, and we'll meet on the next Saturday.
Okay, sir.
Same time.
Thank you.
Yeah. Okay. I'll try to post this in the group when I get my what I am missing. I'll just try to see and work it out. Okay. Bye
Okay,
bye.
sir.
Take care.
Okay.
Closing the session now.